Today's lesson objective, we will look at how to convert word equations to chemical equations, and also the following pages that was assigned earlier. These are the MCQ questions, and also section B, part 1 of all the questions for question 2. So before we get started, let's take a look at the periodic table and write down all the charges so that later when we refer, we can look at all the charges easily. So group 1 form ions of +1 or 1 plus. Group 2, 2 plus, 3 plus. So for group 4, usually they form covalent substances. So they do not form ionic. So I'll leave the charges out. Group 5, charge of 3 minus. Group 6, 2 minus. Group 7 minus. So I will also be drawing the line that separates between the metals and the non-metals. So this is the line. So on the left hand side, these are all the metals. And on the right hand side, these are the non-metals, not forgetting our hydrogen, which is on top. Okay, so having known all this, it will help us to get the charges easily. But also, there are some charges like the polyatomic ions that is listed down here. Okay, so we will have to look at all these later on. So these are some of the common ones. Okay, so what we do now is, let me go through some of the important covalent substances. So covalent substances like hydrochloric acid, okay, are usually in aqueous state because they ionize in water, meaning they form ions in water. These are special covalent substances that can form ions in water. Okay, the rest of the covalent substances are mostly not able to ionize in water, so they stay as covalent substances. Okay, then we also have all the diatomic covalent substances that you learned in the previous chapter. So say for example hydrogen. Okay, the atom has these electrons of 1. In order to make it duplet configuration, which is that of the noble gas, we say it's stable, we will need to have 2 electrons in the first shell. So in order to achieve that, hydrogen form with another atom of hydrogen, and they will share a pair of electrons, and these electrons, if you go and look at one atom, okay, you will see that they have a pair of electrons, which is complete shell. And if you look at the other atom, it will also have the complete shell. Okay, so for hydrogen, nitrogen, if they write in the word equation without the word gas, they are all taken to be the diatomic molecules. So these are the formula you need to take note of. Okay, and these are the state symbols at room temperature. Their physical states as of such. One thing to take note of is that halogens, they are pretty special. They react with water. Okay, so they are able to form aqueous state when they react with water. So in the case where they are reactants in a solution, we can sometimes write it as AQ. Okay, so let's move on. to question 1 that you are given here. Okay, so question 1. Okay, so what you do first is to identify all the reactants and products. So sodium, water, sodium hydroxide, hydrogen gas. So from the words, you can figure out first that sodium reacts with water. So these are the reactants. Sorry, change the size. So these are the reactants. And these are the products. So you will find that all the substance that are given in the reactants are on the left hand side. Then products is on the right hand side. So then next is you can do the elimination method. So this one is wrong formula. So D is out. Okay, then next is to get the formula for all the substance. So you can see that the formulas are all given to you already. Okay, so in a structure question, then we will see how to do the formulas. But since formula is given to you, so let's take a shortcut and write out all the formula first and try to balance. So I will leave out the state symbols here because all the state symbols are all the same. Okay, and don't forget to also make sure you have space in front to work out your formula. Sorry, not the formula, the coefficient for balancing. So I can have a checklist here also. So these are the substances that I need to balance. Na, I need to balance hydrogen and oxygen. Just look at the first part here for the elements. On the right hand side, there will be the same. Next, when you do the balancing, check one by one. Sodium, balance. So I tick first. Okay, hydrogen, H2, but I have 3 on the right hand side. So I can put a half here to make here 1 hydrogen. In doing so, okay, hydrogen is balanced. Next is oxygen. Oxygen has 1 on each side, so it's balanced also. Okay, so if I do the shortcut method that I taught earlier, putting half in equation, you'll be immediately able to spot that the answer is A. Okay, let's move on. For question 2. Okay, if you look at all this, let's highlight again. So ammonia is produced, so this is product. Hydrogen and nitrogen are the reactants because it's produced from. So the substance here, okay, we can eliminate all the other options already. You can see that there is only hydrogen, chlorine, carbon, hydrogen. So directly A answer. Okay, but balancing, this one I will not go through again how to do. Okay, so let's move on to the next question, which is MCQ 5. Okay, so question on MCQ 5, word equation. So word equation here, combustion of ethane. So you have not learned this in set. Usually this topic is learned in air. So combustion means reacts with oxygen. Okay, so react with oxygen. So there's only one that reacts with oxygen. So you can narrow the answer down to D. Okay, so these are all the MCQs that was given. Let's quickly move on to writing word equations for changing word equations here. Okay, these are all the phrasing. These are not actually word equations, but phrasings to describe the reaction. Okay, and you can see that the first part they ask you to do the following. Balance chemical equation with state symbols. Okay, so there's actually 3 steps to doing this. First step, you convert word to chemical equations. Then second thing you need to do is to balance. Then third, state symbols. Okay, I will show you in this order of the steps. So let's do the first one first, converting word to chemical equation. So this step, I will use blue color. So solid magnesium, okay, look at the periodic table, you can find Mg. Okay, aqueous dilute hydrochloric acid. Okay, aqueous, we'll deal with that later on when we do the state symbols. So HCl. Okay, the products form is magnesium chloride. Okay, magnesium chloride you need to work out from periodic table. So look at the periodic table. Magnesium is charge of 2 plus. Chlorine, charge of minus. Okay, so let's go back to the question. So Mg, okay, 2 plus. And chlorine, 1 minus. So let's erase off the plus and minus because this means that they are able to attract and form ionic compounds. So we move down these numbers. Okay, there's no number here to move down. So this gives me the formula of MgCl2. Okay, so formula of magnesium chloride is here. Hydrogen gas is H2. Again, look at here. Hydrogen is, this side. Hydrogen is H2. Okay, then back. Okay, so I have to do write word equations to chemical equations. So Mg, okay, I'm leaving space for the state symbols. I'm leaving space for balancing later on. So reacts with HCl. HCl. Okay, again, space in front and behind, and arrow. MgCl2. Okay, and some space, H2. So just make sure you spread out so that you have all the uh, ways to do. Then the balancing. So magnesium, I have 1 on the left hand side. So checklist for balance. Magnesium is balanced now. Then hydrogen, H on one side is, on the left hand side is 1. On the right hand side is 2. So I put a 2 first. So hydrogen is balanced. Then chlorine is the last element here. So I have 2 chlorine on the left hand side and 2 on the right hand side. So it's balanced. So after I've done the balance, which is step 2, okay, I add in the state symbols. Okay, state symbols, I will use green color. Okay, so magnesium is solid. So remember, go back to here. This is all the elements here. Okay, like metals are usually solid. Metals are usually solid at room temperature. Then you just use the atoms. Okay, so what you can do here is to add in the state symbols accordingly. So just now I was saying using green, solid. Okay, HCl, aqueous. Question already helped you. For aqueous, write AQ. For magnesium chloride, you'll learn in later chapter how to identify whether AQ, solid, and so on. But because you haven't learned that, the question have helped you by saying it's a solution. So solution is AQ. Hydrogen gas, so G. Okay, why is the state symbols important later on when you learn ionic equation? you need to do for part 2. Okay, so let's move on. Magnesium, question done. So let's look at part 2. Okay, so same thing, identify all the substance. I have here aqueous chlorine is mixed with solution of potassium iodide. Okay, color not important here. Solution of iodine is formed. Obtain means form. Potassium chloride is formed. So products is potassium chloride and iodine. Reactants chlorine and potassium iodide. Okay, so I do in the same sequence, blue color for all the substance. So aqueous chlorine formula first. Chlorine is Cl2. Potassium iodide. So potassium, check periodic table is in group 1. Okay, here. Chloride is again Cl minus. So formula I write at the side. Okay, plus Cl minus. So again, I erase plus and minus because it means that it attracts. And then we do the numbers down. Actually, no number here, right? So KCl. Okay, so same thing for iodide. So if iodide is Ki, so I use this way to write. Otherwise, sometimes I, L, all these can't differentiate very well. Okay, so iodine, I2. Chloride, KCl. So putting all the things together and leaving space for balancing. Chlorine, Ki, iodine, KCl, which is potassium chloride. So balance, okay, because there is 2 chlorine here, the other side I have to balance. Okay, so chlorine, balance. Okay, okay, I already added 2 there, so 2 here. Then iodine will naturally be balanced. So this is the balance equation. And let's add the state symbols. Let's follow the question first. Now this one can be AQ because we follow. Sometimes chlorine is a gas, mostly. Okay, it can also be a gas in this equation depending on how the question phrase it. So AQ solution. Okay, solution. Normally iodine is solid. Okay, and this one AQ because there's presence of water, iodine reacts. Okay, but typically when you write iodine as solid is also taken it as correct, especially when you do the ionic later. Okay, so let's move on. Lithium. Okay, so you see the pattern of the question is quite similar. You just need to write out all the formula first. Okay, then salt solution, lithium metal reacts with dilute sulfuric acid, salt solution of these 2 products. Okay, so Li plus H2SO4. Remember to leave some space. Okay, lithium sulfate. So let's move down a bit for more space. Lithium. Okay, periodic table lithium. Let me show you where. Lithium is group 1. Okay, sulfate formula. Sulfate here. Okay, SO4 2 minus. Okay, So let's move on to the formula. Sulfate SO4 2-. So I'm going to erase the charges and do the formula by bringing down the numbers. Okay, so this one you get Li2SO4. So Li2SO4 plus of hydrogen gas. Okay, so after you add in the balancing. So this is a quick balance. 2 lithium on both sides. H2. Okay. Then SO4 is 2-. Okay. Then let's look at the state symbols. Solid AQ, AQ, G. Okay. Sorry. So down to the last two questions. Hopefully I'm still within the 20 minutes time limit for screen. Okay, so that's one. Okay, I will directly highlight for you to see what are the reactants. Okay, now product, silver metal, and a solution. So I can directly write out copper, silver nitrate. Okay, silver nitrate requires us to do the formula. Silver nitrate. So plus, minus. Okay, how do I get all this? Okay, go on to here. Silver is usually plus, sulfate, and nitrate, NO3 minus. So you bring down the numbers. But before you bring down the numbers, I would like to always focus on erasing the plus and minus. No numbers to bring down, right? So this means the formula is Ag and O3. Okay, so let's put it in Ag and O3. Then, I did not give enough space for the state symbols later. Okay, silver metal Ag and copper 2 nitrate. Okay, so this is where there is a Roman numeral of Cu2 plus. So copper, okay, the charge is 2 plus. Then nitrate, charge of minus. Okay, so I will erase the plus and minus first. Then I bring down the numbers, but be very careful here because copper, nitrate, this whole thing is a group, so remember to bracket. Okay, so this is CuNO3 bracket 2. So when you balance this, you see this is one whole group. This one whole group, there's 2. Okay, so when you balance, you go to put a 2 here, you will balance the nitrate. So you don't separate the N and O, otherwise you make your life very difficult. Okay, so after you put this, silver needs to be balanced. Copper is already balanced on both sides, so make a last check later on. Okay, then I add in state symbols. Solid, AQ, metal, right? So solid and AQ. Okay, so I balance part D. Last question, E. So, okay, so when they say aqueous sodium hydroxide was added to a blue solution, so this is both aqueous state and they are the reactants. Reactants. Okay, then next is they talk about precipitate and a solution. Precipitate means that it is, okay, obtain means they are the products. Okay, precipitate means it's solid. Okay, so let me write up sodium hydroxide quickly, formulas. Okay, so all these four you need to write ionic formula. Okay, so I will write here on top Na plus OH minus. Okay, next one is copper sulfate. Next one is copper 2, so 2 plus hydroxide. Next one, sodium sulfate. After a while, you get used to all these numbers. So I will erase all plus and minus first. Okay, so this is 2. So erase off minus, the plus, minus. Okay, accidentally erase my H. Okay, so one shot, I do all the formulas. Okay, same number I cancel out. Okay, so this will work out to be NaOH. This will work out to be this formula. Don't forget the bracket. And then you're done. Okay, so let's put all the things together. Leaving space for state symbols and balancing. Okay, so balance. Let's balance first. Sodium. Okay, sodium here got 2, so I put a 2 here. Okay, hydroxide got 2, so hydroxide, this is what I say. Don't break. See? Don't break, Don't break them apart. And copper is balanced already. Okay, sulfate. Okay, oh, don't break. They are one group, one on each side. Okay, so this is pretty much done except for state symbols. Aqueous. Solution means aqueous. Precipitate. Solid. Okay, be very careful. And also the last one is a solution. Okay, so we are done. Celebration and